So students, now we are going to discuss what do you mean by thermodynamic standard state. So thermodynamic standard state means it is the form in which the substance is more stable at a pressure of 1 bar and a temperature of 298 Kelvin. Means when you are maintaining the condition of temperature and pressure, then that substance is present in the most stable form, and that is called as the standard state of that substance. Temperature criteria is taken as a 298 Kelvin and pressure is taken as 1 atmosphere. Then that substance is having the most standard state, most stable state, and that is called a thermodynamic standard state. So thermodynamic standard state means is the state of the substance in which the substance is having the condition of temperature 298 Kelvin and pressure of 1 atmosphere. It provides more stability, and that is called a thermodynamic standard state. For example, hydrogen gaseous, oxygen gaseous, mercury liquid, sodium solid, carbon graphite, ethyl alcohol liquid, calcium carbonate solid, CO2 gas and H2O liquid. These are the substances which are experience the pressure of 1 atmosphere and temperature of 298 Kelvin. Then these are in a thermodynamic standard state. Clear? So thermodynamic standard state means is a state of substance in which the temperature condition is 298 Kelvin and pressure is 1 atmosphere. Then that substance is found to be most stable one, and that is called a thermodynamic standard state. So these are the substances which are occurring in the nature and they are most stable one. After that, next part is standard enthalpy of reaction, delta RH0. It is the enthalpy change accompanying the reaction when reactants and products involved in their standard state. Means when the reactants and products are in their standard state, then there is some enthalpy change is associated, and that is called as standard enthalpy of reaction. Means when you are taking the reactants and the products and they are having their standard state, then that enthalpy change is associated, and that is called as standard enthalpy of reaction. इसके पहले हमने देखा थर्मोडायनामिक स्टैंडर्ड स्टेट. थर्मोडायनामिक स्टैंडर्ड स्टेट यानी क्या है? जब सब्सटेंस एकदम स्टेबल रहता है. वो मोस्ट स्टेबल कब रहता है? जब प्रेशर रहता है 1 एटमॉस्फेयर और टेम्परेचर रहता है 298 केल्विन. ये जो दोनों क्राइटेरिया है टेम्परेचर और प्रेशर के जब फॉलो किए जाते हैं, तो जो स्टेट मिलती है उसमें सबसे ज्यादा स्टेबिलिटी मिलती है, और इसीलिए उसे कहते हैं थर्मोडायनामिक स्टैंडर्ड स्टेट. उसके बाद है दूसरी, जैसे स्टैंडर्ड एंथैल्पी ऑफ रिएक्शन. इसका मतलब क्या है? जो सब्सटेंस है जिसमें रिएक्टेंट्स है और प्रोडक्ट्स है, रिएक्टेंट्स और प्रोडक्ट्स जो है वो एसोसिएटेड विद एंथैल्पी चेंज. जब वो स्टैंडर्ड स्टेट में है तो उनकी जो एंथैल्पी चेंज होती है उनको कहते हैं स्टैंडर्ड एंथैल्पी ऑफ रिएक्शन. सो दैट्स ऑल अबाउट द थर्मोडायनामिक स्टैंडर्ड स्टेट and standard enthalpy of reaction delta RH0. जब standard enthalpy of reaction बोलते हैं हम, standard thermodynamic standard state, जैसे ऑक्सीजन कौन से स्टेट में? O2 गैसियस, उसमें प्रेशर कितना रहेगा? 1 एटमॉस्फेयर. टेम्परेचर कितना रहेगा? 298. तो हो गया थर्मोडायनामिक स्टैंडर्ड स्टेट. उसके बाद इथिल अल्कोहल C2H5 लिक्विड, इस पे प्रेशर है 1 एटमॉस्फेयर, टेम्परेचर 298 केल्विन, हो गई उसकी थर्मोडायनामिक स्टैंडर्ड स्टेट. उसके बाद CO2 गैसियस, ये सब स्टैंडर्ड स्टेट. उसके बाद है व्हाट इज थर्मोडायनामिक इक्वेशन एंड व्हाट इज द गाइडलाइन टू राइट द थर्मोडायनामिक इक्वेशन. So thermodynamic equation means it is the balanced chemical equation in which the enthalpy change, physical state and number of moles of reactant and product has been specified. Means it is the equation which are giving you the idea about what is happening about the enthalpy change, but that reaction must be, reactant should be balanced, product should be balanced. What are the physical states of reactant? That should be written, whether it's a solid, liquid or gas, and there is also the number of moles of reactant should be balanced. For example, twice H2 means 2H2, twice NaOH means 2, Depending upon the situation, they should be balanced, and that equation is called a thermodynamic equation. So it is the balanced chemical equation in which the enthalpy change, physical states, number of moles of reactants and products have been specified. Means physical state should be specified, number of moles should be specified, its condition and its enthalpy change is also written on the extreme right hand side. All these are associated with one kind of chemical equation which gives the idea about whether heat is absorbed, whether heat is released, and number of moles is balanced. Such a equation is called as thermodynamic equation. So there is a guideline to write thermochemical equation. The example for guideline, you are taking CH4 gaseous plus twice O2. It gives CO2 plus H2O liquid. Actually this reaction is like this, it is balanced later on. CH4 plus O2, it gives CO2 plus H2. Now what is the condition of hydrogen here 4, here 2, so multiply by 2. Oxygen 2 plus 2, 4, here 2, multiply by. Now the reaction is balanced. So look at this. Carbon here 1, here 1. Oxygen here 4, 2 plus 2, 4. Hydrogen 4, hydrogen 4. Now the reaction is balanced. The number of moles is product of reactant is balanced. Physical state of CH4 is gaseous, CO2 is gaseous, CO2 is gaseous, O2 is gaseous, H2O is liquid. That is mentioned. And enthalpy change is written on the extreme right hand side. That equation is called as the thermochemical equation. So it is the equation which is written in the balanced form. Its physical state which should be written, and its enthalpy change is also written, and it's all is concerned with this equation, and such a equation is called as thermochemical equation. Thermochemical equation have guideline to write it. Number 1, first point, balance the equation for the reactant side as well as product side. Just I have mentioned that this reaction should be balanced. Look at this, when methane reacts with oxygen, it gives CO2 and H2. Any hydrocarbon burn with oxygen, it gives CO2 and H2. Now balance it, it should be balanced. Look at this, hydrogen is 4, hydrogen is 2, it is not balanced. Look at this, oxygen is 2, oxygen 2 plus 1, 3, not balanced. Only carbon is balanced, means this reaction is not balanced. You have to balance it first of all. How hydrogen is 4, hydrogen is 2, multiply by 2. Oxygen 2 plus 2, 4, here 2, multiply by 2. Now the reaction is balanced. Means while writing thermochemical equation, the reactants and products should be balanced. The number of moles of reactants and number of moles of products should be balanced. After that, the value of appropriate sign of enthalpy change is given on the right hand side. Look at this, CH4 plus twice O2, CO2 plus twice H2. Here enthalpy change value is written as a minus 890 kilojoule. It is negative sign, means heat is released. Means thermochemical equation is having the equation, but after the end of equation on the extreme right hand side, there the enthalpy change value should be written with appropriate sign, positive or negative. After that, the physical states of the reactants and products should be mentioned. For example, CH4 gaseous, G means gaseous, S means solid, L means liquid, G means gas, and AQ means aqueous. That physical state should be written just below the formula, bottom side of the formula. CH4 gaseous G, O2 gaseous G, CO2 gaseous G, but H2O is liquid, it is written L. But when there is a solid, it is written as S. When there is aqueous, it is written as a AQ. So that is the rule number 3. After that, rule number 4. If the direction of the reaction is changed, then the value of delta RH will be same, only sign will be changed. Look at this reaction. We are changing the direction. This is product, this is reactant. Now product I am writing as a reactant. CO2 gaseous plus twice H2O liquid, it gives CH4 gaseous plus twice O2 gaseous. Delta RH0 is 890 kilojoule, but it is positive. What I have done? I have taken product as a reactant, reactant as a product, means direction is changed. The value of delta RH is 890, but it is minus, but it becomes plus because direction is changed. So that is the rule number 4. When direction of the reaction is changed, the sign of delta RH is also changed. And the last, coefficient is changed. Suppose you are multiplying the coefficient by 2 or 3, then all the coefficients should be balanced on the reactant side as well as product side. For example, you are written reactions carbon solid plus O2 gaseous, it gives CO2 gaseous here. And suppose delta RH0 is minus 740 kilojoule. I am multiplying this equation by 2. So you have to multiply this by 2, you have to multiply by this. Now that is the point. Coefficient is changed, then the total reactant is also multiplied. If it is divided, it should be divided. If it is added, if it is subtracted, that operation should be applied on the left hand side as well as right hand side. So that's all about the guidelines for writing the thermochemical equation. थर्मोकेमिकल इक्वेशन यानी क्या है? थर्मोकेमिकल इक्वेशन ऐसा इक्वेशन है जहां पे रिएक्टेंट बैलेंस रहते हैं, रिएक्टेंट और प्रोडक्ट की फिजिकल स्टेट लिखी रहती है और उसकी एंथैल्पी चेंज जो राइट हैंड साइड में रखी है वो लिखी रहती है, डेल्टा आरएच, इट में बी पॉजिटिव और इट में बी नेगेटिव। ऐसे इक्वेशन को हम कहते हैं थर्मोकेमिकल इक्वेशन। जैसे ये हो गया CH4 गैसेस ट्वाइस O2 गैसेस CO2 गैसेस ट्वाइस H2 डेल्टा आरएच माइनस 890 किलो जूल। ये हो गया थर्मोकेमिकल इक्वेशन। थर्मोकेमिकल इक्वेशन से हमको पता चलता है कि क्या रिएक्टेंट है क्या प्रोडक्ट है। रिएक्टेंट के जो नंबर ऑफ मोल्स है वो बैलेंस रहते हैं, प्रोडक्ट के नंबर ऑफ मोल्स बैलेंस रहते हैं। उसके बाद रिएक्टेंट की फिजिकल स्टेट, प्रोडक्ट की फिजिकल स्टेट लिखी रहती है और एंड में राइट हैंड साइड में डेल्टा आरएच वैल्यू लिखी रहती है। वो एक तो पॉजिटिव रहेंगी नहीं तो नेगेटिव रहेंगी। उसकी गाइडलाइन क्या है वो लिखने की? पहला पॉइंट, the balance should be there, balance equation should be there। जो रिएक्टेंट रहता है और प्रोडक्ट रहता है उसके नंबर ऑफ मोल्स कभी भी बैलेंस रहने चाहिए, तभी उसको हम थर्मोकेमिकल इक्वेशन कह सकते हैं। उसके बाद दूसरा पॉइंट है जो वैल्यू रहती है एंथैल्पी चेंज की वो राइट साइड में लिखी रहती है, वो विद एप्रोप्रिएट साइन होना, पॉजिटिव या नेगेटिव। उसके बाद फिजिकल स्टेट लिख रहती है, जैसे CH4 क्या है? गैसियस, O2 क्या है? गैसियस, CO2 गैसियस प्लस H2 क्या है? लिक्विड। उसके बाद डायरेक्शन अगर चेंज होती है रिएक्शन की तो डेल्टा आरएच वही रहता है, सिर्फ उसकी साइन चेंज होती है और कोएफिशिएंट रहते हैं, अगर वो चेंज करते हैं, हम मल्टीप्लाई करते हैं तो मल्टीप्लाई करना, डिवाइड करना था डिवाइड, ऐड करना था ऐड, सब्ट्रैक्ट करना तो सब्ट्रैक्ट। सो दैट्स ऑल अबाउट दिस। सो नाउ विल स्टॉप हियर।